So in today's video, we're going to be going over the 4 easy steps to solving any trig identity. Let's get into it. Step 1 is just going to be to start on the easier side. And if there is no clear easy side, then we can pick any side. Step 2 is we're going to want to change everything to cosine sine. Step 3 is that if there are fractions that we can add, then we're going to add them. And step 4 is going to be cancel any terms if possible. Now, a couple extra things to keep an eye out for is at each step we're going to check if there's anything that we can factor, like a common factor, or that we can cancel. Also, we want to keep an eye out for this specific trig identity, which is just the rearranged version of our sine squared plus cos squared is equal to 1. But a lot of times questions will throw in this rearranged version, so we got to keep an eye out for this. And our last thing to keep an eye out for is that if in a case where we're stuck with a fraction on each side, what we're going to want to try is multiplying one side by its conjugate. For example, if we have 1 plus sine x on the bottom, we're going to multiply the top and the bottom by 1 minus sine x, which is its conjugate. So let's get into some practice problems. Okay, so we have 3 practice problems to work through here. And just to make it easier to follow, I've put our rules up here to the right, as well as the trig identities that we're going to use in a table there. So let's get into A. So A asks tan of x is equal to sine of x times secant x. So let's get started with A here. And I'm going to start on my left side because if we look at our rules, it tells us to start on the easier side, and that left side looks pretty easy, so we're going to start there. Now, if we look through our rules, our second rule here is to change everything to cosine sine. So that tan, I'm going to change that to sine x over cos x. Okay, and now if we look at our rules here, right, the next rule is if there are any fractions we can add, then we're going to add them, which if we look here, there's no fractions to add in our question. And number 4 is to cancel like terms. Well, there's no like terms to cancel. So our left side, I would say, for now is done. So let's go on to our right side here. And our right side reads sine of x times secant x. So we go back to our rules. We've already started on the easier side. Now step 2, change everything to cosine sine. Well, this is already sine. Our secant, we've got to change into cos or sine, which if we look at our trig identities, our secant is equal to 1 over cos theta. So this will become sine of x, and instead of secant, we're going to have this as 1 over cos x. Okay, and now once we're here, we're not adding these fractions, but they're being multiplied, so we can just multiply these. And when we're multiplying fractions, you just multiply the tops, and there's no bottom for the sine of x, but we can imagine it's over 1, and you would just multiply the bottoms. So we'll get this equal to sine of x over cos of x. And that right there is our first question done. We've got our left side equal to our right side. Okay, let's get into a bit harder of one now. We'll go on to question B here. Okay, and question B reads 1 over tan x plus tan x is equal to 1 over sine cos x. So going back to our steps here, we're going to start on the easier side. In this case, our right side, if we look, we've already got this into changed everything to cosine sine. It's already in cosine sine. There's no fractions to add, and there's nothing to cancel. So our right side's actually already done for us. So let's just write that out first. So our question is 1 over tan x plus tan x is equal to 1 over sine x cos x. Okay, so now that we're here, right, if we do our left and our right side, we said our right side is actually already done. This will just stay as 1 over sine x cos x. Okay, and our left side here now. So thinking about our steps, we've got a step 2 is switch everything to cosine sine. So that's what I'm going to do first here. So this will be 1 over sine x over cos x plus sine x over cos x. Okay, we'll go down to the next page here. So let's continue. So now this will become, if we look here, we've got this here, which is a fraction over a fraction. Now we got to be careful here. But if you remember in one of our past videos, what this ends up becoming, or the way I like to think about it, is 1 divided by sine x over cos x, which if you look here, if you remember your fractions, when you're dividing fractions, all you need to do is flip it. And so this just becomes 1 times cos x over sine x. Okay, and now 1 times anything is just itself, so this will all just become cos x over sine x. So if we look back up here, we can see that it basically just becomes the reciprocal of what it originally was. So if you have 1 divided by something, you just flip it, and it gets rid of the 1 there. And we showed our steps as to why, but in the future, we can just go right to this, right to that flip. So now we didn't touch this sine over cos x, but we don't need to because it already is into sine and cos. So we can just bring this down to plus sine x over cos x. Okay, now at this point, if we go back up to our rules, actually let me bring this down here, right? If we're looking at our rules, step 1, we started on the easier side. Step 2, we changed everything to cos and sine. Now step 3, if there are fractions you can add them. So right here, we have fractions we can add, so let's add them. Now to add these fractions, we need to find a common denominator. Now the way we do that with our trig identities is if we look at this side, our left side, right, it just has sine and our right one just has cos. So what we need to do is our left side here, we need to multiply. In order to match the bottoms, we got to multiply both the bottom by cos x and the top by cos x. And this one over here, right, we've got to multiply the bottom by sine of x and the top by sine of x, right? Because whatever we do to the top, we must do to the bottom and vice versa. So now what we're going to have is cos x over cos x sine x plus sine x over cos x sine x. Okay, so now our bottoms match. And if we look here, cos times cos, right, and sine times sine, all that will become is cos squared x, and our bottoms are still the same, just cos over sine. So cos x sine x plus sine squared x. And once again, the bottoms are the same. Now, since our bottoms are the same and we've simplified the tops, when we're adding fractions, we just add the tops. So this will become cos squared x plus sine squared x all over cos x sine x. Okay, now we're getting close. Let's go back up to our rules here. So step 4, cancel like terms if possible. Well, there's nothing to cancel here. So let's go to our extra hints, right? And in our extra hints, it says each step we want to check if there's anything we can factor or cancel. Okay, there's nothing we can cancel or factor. And then it says keep an eye out for this rearranged trig identity, right? Which if we look here, it's just this trig identity, or one of our Pythagorean identities. Sine squared plus cos squared is equal to 1. So let's go back down here. Well, we have cos squared plus sine squared, and the law of addition, order doesn't matter. So what this is going to equal to is just 1, right? So that top will just equal to 1. So now we'll have 1 over cos x sine x. And that's what our left side is equal to. So our left side is equal to 1 over cos x sine x. And if we come back up here, that's what our right side is equal to. So That means our right side was equal to 1 over cos x sine x. So we have our left side equal to our right side. Okay, so let's go on to part C now. In part C, let's bring this down here as well. Part C reads that 1 minus sine x over cos x is equal to cos x over 1 plus sine x. Okay, so if we start here, now both sides look equally as hard to me, so let's just start with the left side here. Okay, so our left side, right, and that is equal to 1 minus sine x over cos x. Okay, and our right side is cos x over 1 plus sine x. So if we look here, they almost look like the reciprocals or opposites of each other. Now, if we go up to our rules, right, and I'm going to bring another set of this down here as well. So if we're looking at our rules here, let's just follow along these. So start on the easier side. We chose our left side. Change everything to cos and sine. Well, everything already is cos and sine, so step 2 is done. If there's fractions we can add, we want to add them. Okay, well, there's no fractions to add. And step 4 is cancel like terms if possible. Once again, no like terms to cancel. So let's go down to our extra hints here, right? And I want to look specifically at this last hint. If you get stuck with one fraction on each side, try multiplying one side by its conjugate. So we're stuck right here. There's one fraction on each side. So we're going to try multiplying one of these by its conjugate. So let's do our left side. And just to remember, what our conjugate is, for example, 1 minus sine x, its conjugate would be 1 plus sine x. Okay, and whatever we do to the top, we've got to do to the bottom here. So we're going to multiply both by that there. Okay, so let's see what this gets us here. Okay, so we have, now we're going to have 1 minus sine x times, okay, times 1 plus sine x all over cos x times 1 plus sine x. Now on the top here, we're going to have to do our FOIL. So let's go through this. So first, 1 times 1 is just 1. Our outsides, 1 times sine x is sine x. Our inside is negative sine x times 1, so that'll be minus sine x. And our last here is negative sine x times sine x, which will be negative sine squared x. Okay, and our bottom here, we just need to distribute this cos in. So this will become cos times 1 is cos x plus cos x sine x. Okay, now if we look up top here, right, we have 1 plus sine x minus sine x. Well, these are like terms, and it's a positive and a negative. So these will cancel each other. So we'll be left with 1 minus sine squared x over cos x plus cos x sine x. Okay, now going back to our steps over here, right? We've started being able to do some stuff here, so we're not stuck anymore. But if we look at this other extra hint, keep an eye out for this rearranged trig identity. So the trig identity it's referencing is our sine squared plus cos squared is equal to 1. So if we look here, 1 minus sine squared x, which is what we have over here, that is just equal to cos squared x. So let's sub in that identity there. So instead of 1 minus sine squared x, we're just going to have cos squared x all over, and if we look at the bottom here, right, I know we expanded this out earlier, but here's where trig identities, there's a bit of guess and check to it, because I expanded this out, but now let's try factoring out these coses and see what this gets us. So if we try factoring out that cos x, we're back to just cos x times 1 plus sine x. Well, here, if we look, we have cos squared x on top, right here, and cos x on the bottom. Well, we can cancel one of this cos squared with that cos. So we'll just be left with cos x over
1 plus sine x. Okay, and if we scroll back up to the top now, our right side at the start of this question was equal to cos x over 1 plus sine x, which is what we have now. So we just proved that our left side is equal to our right side. We'll write it out here just to show it. So left side is equal to right side. And you can see here by following this table of steps, we can solve any trig identity. As long as it takes a bit of patience and got to go through each of the steps and look out for those extra hints. But you can solve any of these trig identities with these steps right here.